Spanning set. Okay, let's calm down. I was crazy. Okay, definition, subset. Let's calm down. All right, so we have two sets. Let X and Y be two sets if all elements of X are also element of Y, then we say that X is subset of Y, and we denote this way: X subset of Y, right? Subset, and we denote it this way, right? So it's like this: Y and X. Yeah. So X is a subset, and X, Y. Yeah, X is a subset of Y. Okay, now linear combination again. This is very familiar now, right? Linear combination. Okay, definition. So linear combination. Let V be a vector space, 10 axiom. And let V1, V2, Vn is a subset of vector space. A vector V is element. Yeah, it's in V, or we said element of V, right? It's called linear combination. Of V sub I, if there exists scalars C sub I is in R real number, right? Such that, so we have this form. So vector V, scalar C sub 1, vector V1, plus C2, vector V2, plus C3, vector V3, until whatever they have, C sub n, V sub n, right? So linear combination, we might think sum of vectors with scalar multiplication, right? Okay, now span of vectors, there's another terminology. So let me write down. So definition, we have a span of vectors. Okay, let set of V1, V2, Vn is in vector V. Then span V sub 1, V sub n, it's a set of summation of I equal to 1 to n C sub I and vector V sub I, and they're using, this is same as such that C sub I is in R. Okay, can anyone recognize this? What is this?
The sum?
No, I mean this one. I mean everything.
No,
5? Can anyone recognize this? Yeah, this is the same as this one, isn't it? Can you see that? This is the same as that. It depends on how many vectors there, right? But this is exactly until n, right? Yeah, they're using just summation. This is expand. Yeah. Okay, then we can express that span of vector v sub 1 and v sub 2, whatever, right? Vectors, right? Then we can express, then let me write down. Span V1, Vn means okay, let me write down W because we denote W. W is in span. W is in span. Means W, vector W can be written as linear combination of vector V1. Okay. We said a collection of vectors V1, V2, Vn is a spanning set for vector V. Okay, then we are using these vectors is a spanning set for vector space V, right? Okay, then we said if V equal to span of vector V1, V2, Vn. Okay, so a little bit hard, right? But it's terminology, right? So span. So think about reading, we can write as a linear combination, right? Okay. So in general, span of vectors, so set of all linear combination. combination. Okay, let us do a couple problems here. Matrix. Let A equal to 1, 0, 0, 2, and determine if A is in span M1, M2. It's a span. So what's the M1? M1 is given like 1, 0, 0, 0, and 0, 0, 0, 1. Okay, so we are going to make a linear combination, right? So let's say that this A is in span. This means, look, V equal to span, right? So that is, we can express as a linear combination. Oops. So let A equal to, since this is M1, this is M2, so linear combination is the sum of a scalar multiplication. So we can express as A M1 plus B M2, right? So A is in real number, also B is in real number, right? Okay, so let us talk about that. So we have, ooh, that was quick. I remember that. Okay, so A equal to 1, 0, 0, 2. Okay, let's think about A 1, 0, 0, 0 plus B. Okay, thank you very much. Theorem says, okay, 0, 0, 0, 1, right? Okay. What is A will be? Oops, sorry about that. Hold on 1 second. Is equal to yeah, thank you. I got it. Yeah. A. So what do you think about A and B?
A is 1 and B is 2.
Excellent. Okay, let's check that. So 1, 0, 0, 2, 1, 1, 0, 0, 0, 2, 0, 0, 0, 1. So there will be 1, 0, 0, 0 plus 0, 0, 0, 2, right? So we got 1, 0, 0, 2. Yeah. Very good. All right. Let us do one more, then we finish today. Two more. So let us do this one. Show that P over X equal to 7X squared plus 4X minus 3 is in span 4X squared plus X, X squared minus 2X plus 3, right? So once again, like earlier, right? So A is in span, right? Then we can use it like that, and we are looking for the scalar multiplication, right? So same as here. So we are going to write down P over X equal to 4x squared, hold on 1 second, plus x with a scalar multiplication and plus x squared minus 2x plus the 3 and scalar multiplication and then p over x, which is, let's using p over x, change that, right? So 7x squared plus the 4x minus the 3. Okay, now so we have a 4a, we distribute to 4ax squared plus ax, right? And plus the bx squared minus 2x bx plus the minus, please fix me if I make a mistake, bx plus the 3b, right? Okay, so x squared, so 4a plus b, x squared plus, yeah, ax, that x term, so 4a minus 2b, x term plus 3b, right? Okay, now it's a corresponding. So we did a calculus too, this kind of stuff. So we have 7x, this x squared, I'm sorry, 7x squared corresponding that. And we have this one corresponding that, right? And we have constant term corresponding that, right? Okay, so we get 4a plus b equal to 7, 4a minus 2b equal to 4, and 3b equal to -3. Okay, now, did I make a mistake here?
Is that 4a correct? 4a minus 2b, shouldn't that be just a minus 2b?
Yeah, so correct. So this is a, right? Yes.
Yeah, a minus 2b, yeah.
Thank you very much. That's why I'm asking you. Looks like not correct. Okay, thank you. So should it be a? Yeah, this is a, right? Okay, now we have b equal to -1. Then we substitute here a minus 2, -1 equal to 4. So a equal to 2. Okay, good. Let's check that. 4, 2 plus -1, is it 7? Yes. Yep. Good job. Okay. So we can find the scalar multiplication there, right? So we can have that. Let me copy this way. So this is form of linear combination. Copy. Okay, so a equal to 2, and then b equal to -1, right? So a equal to 2, b equal to -1. Okay, so we got that. Over x is in the span. Okay, let us do just one. Let us just do one more. All right. Okay, just 5 minutes. All right. Yeah, just 5 minutes. So we have a matrix is not B. B equal to -3, 8, 1 is a span of U sub 1 equal to 1, -2, 3, and U sub 2, 5, -13, -3. Okay, how do you do? Same, right? So we have -3, 8, 1 equal to, yeah, we set up the augmented matrix, 1, -2, so we have A, 3, plus B, 5, -13, -3, right? Okay, so augmented matrix, we can just using x of 1, x of 2, x of 3 like that, right? So let us using that. So we will have 1, 5, -3, and -2, -13, 8, 3, -3, 1, right? Okay, now we are finding solutions, right? So we want to make like reduce row echelon form. We want to make a row echelon form. Okay, so this will be, ooh, are you sure? Yes, yes, I see what you meant. Okay, correct. So we have make a 0 here. What do you get? How we want to make a 0 here.
Yeah, add to row 1.
So 2, 1, 5, -3, 2 R1 plus R2 to get R2. So we have 0, -3, 2, 3. How about here? We make a 3, -3 R1 plus R3 to make R3, right? So we get 0 and -15, -18, and -9 plus 1, it's -8, correct? Okay, we get -10, okay, okay. Negative, it's a positive, correct, yes, it's a positive. Thank you so much, it's a positive. Okay, it's a positive. All right, then we want to make a 0 here. Okay. 0 here. So how
Add
do you,
6 of row 2.
excellent, yeah, add 6, yes. So we get 6R2 plus R3 to make R3, right? So we have, you guys, excellent. So 1, 5, -3, 0, -2, 2. Okay, so negative, correct. Yes, thank you. Correct. During message, we have 0, 0, -2, 12 is -2 then. Yeah. Okay. Look, the last term, not last term, last row, we have a 0 equal to -2, which is a false, right? So we don't have there is no solution. It's okay. So vector V is not span of U1, U2. It's okay. Any question? Okay, thank you for coming. You have a nice evening. I will see you tomorrow.
All right, thank you.
Thank you. Bye.